Hi everyone. Today we're going to be discussing drawing ray diagrams for curved mirrors. So just a quick little tidbit of information. All rays in this video will begin at the top of the object, and the object will always be represented by an arrow, so you'll know what I mean when we get to the ray diagrams. So first, before we start drawing these ray diagrams, we have to recognize what types of mirrors we're using. So they will be curved mirrors, but there's two types we're going to talk about today. So the first type, we have concave or converging mirrors. Whenever you hear concave or converging, they mean the same thing. Okay, so concave and converging mirrors, they are mirrors that will bend light inwards and have the ability to focus light. An easy way to remember what a concave mirror looks like, when you are looking at the object, so I'm just going to circle the object quickly. Again, it's going to be represented by an arrow. When you're looking at the object and in comparison to the object, the mirror is going to look like a cave. Okay, so here's the mirror right here. I'm just going to redraw that circle. So this is the mirror right here. Okay, and in comparison to the object, it kind of looks like a cave, almost like a cave opening, right? And the next type of mirror that we're going to look at is called a convex or converging mirror. I have convex. I'll put that there. Let's erase that. So we have convex or a diverging mirror. Okay, so it's pretty much the exact opposite in comparison to a concave mirror. When we're looking at the object and in comparison to the mirror, it's just facing the other way. So that cave opening is facing the opposite way. So you might see we have the letter C here, and we also have the letter F, what those mean. So if we scroll down, we're going to look at the different parts of ray diagrams. Okay. So again, the object is always going to be represented by an arrow. Just right here, you'll see the object. This horizontal line running across, it's called the principal axis. Okay. In this case, we have a concave or converging mirror. And finally, we have this F, and we also have C. So what the C stands for is center of curvature, and what the F stands for is the focal point. Okay, so how these points are actually found on the principal axis. If we were to extend this concave mirror into a complete circle, so this isn't going to be perfect, but it's just to show what the center of curvature and focal point are. If we were to extend this mirror into a circle, again, that's not a perfect circle, but you will find that the center of curvature, so this point right here, it's the radius of the circle if the mirror was extended into a complete circle. So the center of curvature is just the radius of this theoretical circle. What the focal point is, it is just half of the radius. Okay, it's always half of the center of curvature. So let's say the radius of this circle is, I don't know, this is for example 6 centimeters. Okay. If we know the center of curvature, we can easily figure out the focal point or the focal length, because it's always going to be half of C. So it's just going to be 3 centimeters. That's all. Okay, so that's what the center of curvature and the focal point mean, what those points are on the principal axis. So let's scroll down to some rules that we have to follow while drawing ray diagrams for curved mirrors. So the first rule is that the first ray will go through the focal point, then reflect back parallel to the principal axis, or through the principal axis, sorry. The second rule says that the second ray will run parallel to the principal axis, then reflect back through the focal point. So 1 and 2 are kind of opposites of one another. And number 3, it says the third ray, if possible, because it's not always going to be possible to use rule number 3, but it's going to run through the center of curvature and reflect back along the exact same path. Okay, so you'll know what I mean for number 3, how it's not always possible if we get into some more examples here. But let's go through the first 3. So the first one here, let's identify what we have. Looks like we have a concave mirror. So we have a concave mirror. We have our focal length right here, and we also have our center of curvature right here. We have our object represented by an arrow right there. So I'm just going to quickly erase my little arrows here so we have a clean slate. All right. So the first rule, we are going to run a ray parallel to the principal axis, like so. Okay. And then we're going to reflect this ray off of our concave mirror through our focal point. So let's line it up. And this ray is going to reflect like so. And make sure to draw the direction of the ray. So it should look like this so far. Rule 1 is done. We went parallel to the principal axis, reflected off of our concave mirror through F. So our second ray is going to go through F. So we can draw a ray that goes through F. It's going to reflect off of our concave mirror and run parallel to our principal axis, like so. Okay, so rule 1 and rule 2 are both successful. We're looking good. And finally, rule 3, we can use it because our object is behind C. Our third rule is that our ray will run through C, reflect off of our mirror along the exact same path, and end up like so. I'll take our ruler away. So all 3 rays are drawn. Now, where does our image end up? And I'll tell you where. So we do have a point on our ray diagram where all 3 reflected rays intersect, and that area is right here. I'm just going to draw a quick red circle. So that area is right there. So how we can draw our image, we will start at the base of our principal axis, and we will draw our arrow like so. So our the top of our image, or the top of our image of our object, will follow where our 3 intersected, or our 3 reflected rays intersect. So we'll draw from our principal axis to the intersection, and that will be our image. Okay, so we'll circle it right here to make it a little bit more clear. But that is where our image will be. So we can write down some characteristics of this image. So first off, magnitude, or magnification, sorry. Compared to our object, our image is just smaller, so we can write that. So we have smaller. Since our image is on the same side of the mirror as our object, this is a real image. That means it can be projected onto some type of screen. Okay, so it can be projected. We can also say that our image is inverted or upside down. So it is inverted. And finally, we need to write some kind of position as well. So since our image is between our center of curvature and focal point, or focal length, we can write down between C and F. Okay, so between C and F. Perfect. So that is our first example. Our second example, a little bit different. We have a convex or diverging mirror. So we can still use the same rules, but we might have to adjust them just a little bit. So if we pull out our ruler here, let's look at rule 1. So rule 1 says our first ray is going to run parallel to the principal axis and reflect through F. Okay, so we need to line up our original ray with F, and it is going to reflect at that angle. Now here's where these can get a little bit tricky. Since in a convex or diverging mirror, our image will be able to be found in the mirror, we need to draw our rays running into the mirror, because that's where our image is going to be found. So we can represent that with dotted lines. So our first rule should look something like this. We have parallel and then reflect through F. Our second rule is where people usually mess up. So we will line up with F first. Next, we will draw our ray hitting the mirror, but as soon as this ray hits the mirror, we do not continue through F. We reflect parallel to the principal axis. Okay, so it never actually makes it to F. And again, we need to draw our dotted lines representing our virtual ray into the mirror. And I'll finish up with direction. Finally, we have our third and last rule we can follow here. Our ray is going to run from the top of our object and through C. And since rule 3, there's no change in angle or direction of our ray, it's just going to reflect along the exact same path. Make sure we're lined up. This looks good. Perfect. Okay, put away our ruler for now. And again, we do see our rays intersecting somewhere. This time it's on the opposite side of the mirror compared to our object though. So let me pull out a red marker here, draw our image, and it should end up right there where all three of our virtual rays intersect. And again, we can actually write down some characteristics to this image. So first off, let's do it in the same order we did the last one. So again, our image is going to be smaller than our object. We can write down smaller. Next up, because it's on the opposite side of the mirror compared to our object, our image is going to be virtual. So it can be found within the mirror. If you were looking into the mirror, this image is found in the mirror. Next one, it is right side up. Okay, so we can just say that right side up, that's fine. And finally, we have to write down the position. So this time our image is between the mirror and our focal length. So we can just write down between mirror and F. Okay. So again, our four characteristics: we got a smaller image, we have a virtual image, we have a right side up image, and we also have our position being between the mirror and our focal point or focal length. Finally, our next and final main ray diagram we can do, we have a concave mirror or a converging mirror. But this time, notice where our object is. It's in front of F, so it's pretty darn close to the mirror. So we can follow the same rules here. Again, we might need a little bit of an adjustment on some of them, but we should be able to use them quite effectively. So our first rule, again, our ray is going to run parallel to the principal axis, and it's going to reflect back through F. So there's our first rule. Now I'm going to let you in on a little secret. When you have an object that is in front of F on a concave mirror, you should always think to yourself, this is going to be a virtual image. This image is always going to be found within the mirror. So because I know that, I'm going to extend rule 1 into the mirror like so, just with some dotted lines, and we'll see if it pays dividends when we come back to when we're finding our image. So we have rule 1 done. Let's think about rule 2 here. Rule 2, we have our top of our object and F lined up. So we have our second ray running on that same angle from the top through F. It's going to hit the mirror and reflect parallel to the principal axis. And again, I'm going to extend this line into the mirror, represented by just those dotted lines. Okay, so this looks good so far. We're starting to see where our image is going to end up. Finally, our third one, we can use rule 3 here. So line up the top of our object and C. Just make sure, there we go, perfect. So our line is going to run at that angle from the top of our object through C, reflect back at that same angle. But again, I'm going to extend this line into the mirror by dotted lines. We have all 3 of our rules complete. Put away our ruler for now. Now, we do not see, I'm just going to draw our arrows here, which way the light is going. We do not see any intersections on the same side of the mirror as our object. But if we look on the opposite side, if we look on this side of the mirror, we do see an intersection. Okay, going to bring back my ruler real quick. Let's draw our image, because we see an intersection right here. Okay, so again, when we see an intersection, that's where our image is going to be. So let's draw our image where our intersection is. Oh, that is our eraser. Let's bring out a marker. There we go. Perfect. So our image should be found right there. So again, we draw it from our principal axis to where our intersection is. We see our image end up right there. Okay. We can just end off by writing out our characteristics. We have a larger image. It is virtual because it's on the opposite side of the mirror. We also have a upright or right side up image. So I'll just write upright. And our position, because we don't have our focal point, we don't have our F, or we don't have our center of curvature on the side of our image, we can just write behind the mirror, because the mirror is the only thing we can compare our position to. So we can just write behind the mirror. Okay. So I'll give you one more look at our ray diagram. We have our 4 characteristics, and that looks good to me. I hope this video has helped.